using the ratio test to determine whether the series is converged or diverged. This is going to be really fun. So first we have a series. So the ratio test is all about comparing the current term and the previous term. So the current term, the nth term. So we have an, which is the series, which is n divided by 5 raised to the nth power, and then the next term n plus 1. So you replace the n with n plus 1. And then we have limit as n approaches to infinity. We have the absolute value of an plus 1 divided by an. That is equals to limit as n approaches to infinity. So we have the top divided by the bottom, right? So we have n plus 1 divided by 5 to the n plus 1. So divide, you have a fraction divided by another fraction, which is you have the top multiply the reciprocal of the bottom, right? That is 5 raised to the n divided by n. This is fun, and this is called reciprocal, just to let you know. All right, let's break down the exponents. So n approaches to infinity. This is n plus 1, no surprise. And then the 5n plus 1 is 5 to the n times 5 to the first, and then 5 to the n divided by n. So we can do some cancellation, the 5 to the n and the 5 to the n. And then we have limit as n approaches to infinity, n plus 1 divided by 5n, right? And then this one is infinity over infinity. Either you use L'Hopital's rule or you use another method. So speaking of L'Hopital's rule, you apply L'Hopital's rule when you have 0 over 0 or infinity over infinity. So speaking of L'Hopital's rule again, I have video in my channel that I fully explain what L'Hopital's rule is, and then I have a bunch of examples. If you don't remember L'Hopital's rule at all, you can watch those videos, but this problem is simple enough. We don't really need to go to L'Hopital's rule. So all we have to do is we divide each term by n, yn, because the bottom, the highest power is n raised to the first power. If the bottom is 5n squared, then we divide each term by n squared. All right, back to the algebra. We have limit as n approaches to infinity. Then we have 1 plus 1 over n. Again, we divide each term by n. And then the bottom is 5n divided by n. That is 5. So once n approaches to infinity, we have 1 plus 0 divided by 5. So that is equals to, not 5, that is equals to 1/5. 1/5 is less than 1. What does that mean? That means the next term is less than the current term, right? So we have the next term divided by the current term. So the next term is less than the current term. As a result, so we have a series, right? A1 plus A2 plus A3 plus A4 and then plus A5, and then we keep on moving. So we have an AN and then AN plus 1. So the next term is less than the previous term. That means as n approaches to infinity, these numbers, they are getting smaller and smaller. As a result, the sum is determined by the first couple numbers, and therefore the entire series is absolutely convergence by the ratio test. So that completes this problem. All right, so let's moving on to number 2. So number 2, we have more complicated problem, and this problem you have to do a lot of work to get to the answer. Number 2, you have a sum, n goes from 1 to infinity. You have -1 raised to n plus 1, and then the top you have 3 raised to the n, the bottom you have 2 raised to the n, times n raised to the third. So first we have to identify the nth term and the next term. So the nth term is an, which is the series raised to 3n and then 2 to the n times n raised to the third power. And then the an plus 1. So you have to replace the n with n plus 1. So that is 2n plus 1. This is a n plus 1 raised to the third. And then 3 raised to the n plus 1. And then this is -1 n plus 1 plus 1. Then that will be n plus 2. So you got a lot of algebra to do right here. So start the ratio test. We have limit as n approaches to infinity. Absolute value, the next term, divided by the current term. So we have the top multiply the reciprocal of the bottom. So an plus 1. So this one you can start breaking down the power. So negative 1 to the n, and then negative 1 square. So you just break down the power, right? N plus 2. And then the denominator, 2 raised to the n, 2 to the first, 3 to the n, 3 to the first. And then the n plus 1 raised to the third, you don't need to expand that. And then the reciprocal of an, so the top you have 2 to the n, and then n to the third. And then the bottom, negative 1 raised to the n, negative 1 raised to the first, and then 3 to the n. The next step is what makes this problem so fun. All right, let's do some cancellation. 2 to the n, 2 to the n. What else? Negative 1 raised to the n, negative 1 raised to the n. Anything else? We have 3 to the n, and then 3 to the n. So that means the bottom we have a 3, we have a 2 times the third power. The top we have a 3 times n to the third. Or what about this negative 1 squared? The negative 1 squared is just equals to 1, right? So let's go back to green. We have limit as n approaches to infinity. We at the top we have 3n to the third, right? So which means let's isolate the numbers and the variable. So 2, and then this is a n to the third divided by 1 n plus 1 raised to the third, right? So this is what we can do. So we can just take the 3 over 2 out. So this is a limit as n approaches to infinity. So keep the absolute value. So we have the third power, right? So this is a n divided by n plus 1. In case you have no idea how I got to this point, do you still remember this? A to the third power divided by b to the third power, that is equals to a divided by 3 raised to the third power. So this is the law of exponent. And then inside the parentheses, since the highest power is 1, I will divide each term by n raised to the first power. And then we perform the algebra. Limit as n approaches to infinity. We have, so absolute value, and then we have 1 divided by 1 plus 1 over n, and then the whole thing raised to the third power. That is not too important because as n approaches to infinity, the 1 divided by n is just a 0. So we only have a 1 divided by 1 plus 0 raised to the third power. So the result is equals to 3 over 2. That is greater than 1. And then what is the concept? We have a1 plus a2 plus a3 plus a4, and then all the way to an, right? Plus an plus 1, and then we keep on going. So we have the ratio is the previous term divided by the current term, and then you get a result that is greater than 1. That means the next term divided by the current term, that means the next term is greater than the previous term. As a result, if you keep on going, the numbers are getting bigger and bigger. Another way to say this is the numbers, the way you write the a1 to an is in ascending order. So for example, if you're adding up numbers like that, 1 plus 2 plus 3 plus 4 plus 5, and then you keep on going, plus 100 plus 101, and then you keep on going. So you take the next term divided by the previous term, that is greater than 1. That means the numbers are in ascending order. In this case, these numbers will make the sum so big, so the sum is going to be equals to infinity. As a result, the series is divergent by the ratio test. RT, divergence by the ratio test, because the sum is going to be equal to infinity. So we say that the entire series is divergent using the ratio test. All right, so that would be the end of number 2. Let's move on to number 3. So problem 3, we have the summation. N goes from 1 to infinity, and then negative 3 raised to the n divided by 2n plus 1 factorial. This is our first time working with factorial, right? If you don't know what factorial is, let's say 5 factorial, that is equals to 5 times 4 times 3 times 2 times 1. Do not multiply 0, because once you multiply 0, the whole product is equals to 0. And there is a special case. I don't think you will see that in this type of problem, which is 0 factorial equals to 1. That is a special case. So let's identify the nth term, which is just the series. So negative 3 raised to the n divided by 2n plus 1 factorial, and then the next term plus 1, so that is a negative 3 n plus 1 divided by 2n plus 1, that is equals to 2n plus 2, and then you add 1 to it, so that will be 2n plus 3 factorial. So now let's set up the ratio. We have limit n approaches to infinity, the next term divided by the current term n. So that is a limit as n approaches to infinity. We have the next term, that is a negative 3, time to break down the powers. So you don't need to write an extra step to the n, and then negative 3 raised to the first divided by 2n times 3. So this one I will just hold on to that. I'm not going to write it out right now. And then the reciprocal of an, that is 2n plus 1 factorial divided by negative 3 raised to the n. And then we can see that the negative 3 raised to the n will be cancelled, right? Now, here is why I like this type of problem so much. Do you see that we are supposed to have 2n raised to the 3? And then according to the factorial right here, the next term is the decrement of the previous term. Decrement of what? Decrement of 1, right? So 3 is 1 less than 4, 2 is 1 less than 3, and 1 is 1 less than 2. So that means here is the technique that you must learn in the ratio test, the factorial, the 2n plus 3. We start with the first term, 2n plus 3, and then decrement by 1, 2n plus 2, and then 2n plus 1, right? We have a 2n plus 1 on top, so we stop right here. And then we get rid of the factorial. You must be able to do this on a ratio test, and this thing shows up all the time. And then the top, the absolute value of negative 3 is just equals to 3. All right. So back to this problem, we have limit as n approaches to infinity. What do we have? We can take the 3 out, right? And then inside the absolute value, what do we have? We have 1 divided by 2n plus 3 times 2n plus 2. So once n approaches to infinity, you have a 3 divided by 1 over infinity, which is what? Which is 3 times 0, which is equals to 0. And 0 is less than 1. So 0 is less than 1. What did we just do? We just take the next term divided by the current term, and then we have this fraction is less than 1. So the only way to say this is the next term is less than the previous term. So in what kind of series do we have this? When the numbers are in descending order. So let's say we have a 20, 19, 18, just for example. I'm not saying this is the terms of this series. And then 17, and then 16, and then all the way, right? So if you take the next term, compare that with the previous term, the next term, the current term is less than the previous term, right? So 16 divided by 17, so this is less than 1. So that means as you move on to the end of the series, these numbers are so small, something like close to 0, which means in the meantime, the sum is determined by the first couple numbers. As a result, the sum is determined by the first couple numbers. So when you reach to the end of the series, you are adding zeros to the sum. So overall, the sum is equals to a real number. So therefore, this series is absolutely convergent by the ratio test. That is how you answer this question. All right, so that is the end of number 3. Let's take a look at number 4. So number 4, we switch to another color. Number 4, we have the sum. K goes from 1 to infinity. Oh, simple series, just 1 divided by k factorial. Looks like I really want you to practice your factorial skills. So an equals to 1 divided by k factorial. and then an plus 1 is not really n plus 1, right? That would be like k plus 1. All right, I will change that to k plus 1 and ak. So that will be 1 divided by k plus 1 factorial. And then we do the limit as n approaches to, so that will be k approaches to infinity. And then this is ak plus 1 divided by ak. And then that is limit as k approaches to infinity. We have 1 divided by, I will not write the factorial for now. The reciprocal of ak is k factorial divided by 1. So the k factorial, the k plus 1 factorial, then that will be k plus 1. The next term is a decrement by 1, so plus 1 minus 1. That gives you a k, and then you stop that with a factorial. The reason is you want to get rid of these two factorial. Let me remind you this. When you work on a ratio test, you must get rid of the factorials. If you cannot do this, the result is wrong. Let me say this again. You must get rid of the factorials. Again, you must get rid of the factorial using this kind of skills. Otherwise, the answer is wrong. Okay, so back to this problem. So we only have limit as k approaches to infinity, absolute value 1 divided by k plus 1. So once k goes to infinity, you have 1 divided by infinity, which is a 0. 0 is less than 1. What does that mean? That means you have the, just let's say you have a series. You have A1 plus A2 plus A3 plus A4, and then you go all the way, right? So when you have this less than 0, the only chance is the next term is less than the previous term. So that means something like that. So let's say you have 30 plus 29 plus 28 plus 27 plus 26, and then you keep on moving, right? So this is an plus 1, this is an. So when you take 26 divided by 27, the result is less than 1. That means as n approaches to, as n or k approaches to infinity, these terms, they are so small and they are close to 0, which means the sum is really determined by the first couple terms, and therefore the sum is equals to a real number, not infinity, and therefore this series is convergence by the ratio test. All right, that's how you do it. And please practice your factorial skills. So overall, if you think my instruction is helpful, let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. Appreciate your help as always. In the next video, I will give you more examples regarding the ratio test. So I see you all in the next video. Signing off for now.